This is an activity on naming alkanes. And in the beginning, it's just stuff for you to read through. So read through all the instructions. And the biggest thing when you're naming or you're going from a name to a drawing is to follow the rules. You have to follow the rules. So I'm not going to read all this stuff to you. I figure that you can read it. And I want you to go in and I want you to try the whole worksheet, then come and watch the video. So I'm going to assume that you have read everything and you have tried everything. So when we talk about naming things, we have to be able to distinguish between what is the parent chain and what are the substituents. So the substituents are always going to end in YL, and they're always going to have a prefix that indicates the number of carbons that are in the chain. So if it's methyl, there's 1, ethyl, there's 2 carbons, propyl is 3. And we'll talk about isopropyl in a second, but just remember, me eat peanut butter in the pentagon, right? So methyl, ethyl, propyl, butyl, and pent, right? Me eat peanut butter, and then in the pentagon it's pent. Okay, so this is saying the rest of the molecule is attached to this. So we have, and this R is the parent. So we're not going to draw the parent. We're just going to say that this CH3 is somehow attached to the parent. So we do the same thing for ethyl. So ethyl is 2. So remember that if I put a carbon here, I could only put 2 more hydrogens if I'm going to attach another carbon. So I have to write that as CH2, then CH3. So be careful not to give too many hydrogens to the carbons. Propyl, we're going to do the same thing. Okay, and this one is 3. So the first carbon is going to have 2. The second carbon is going to have 2 hydrogens, and the last carbon is going to have 3 hydrogens. Now, isopropyl is just a isomer of propyl. And remember when we said isomer, it's a structural isomer. So all we're going to do is rearrange the carbons. We're still going to have 3 carbons, but instead of this last carbon being on the end, what we're going to do is we're going to take it and attach it to the first carbon and make isopropyl. So we're going to have 1 carbon, and it's going to be attached to the second carbon. And then that third carbon is going to go down at the bottom. And so now go in and add in your carbons, your hydrogens, in order to make your octets match. So that carbon right there gets 1 hydrogen. Then this carbon right here gets 3. And then the last carbon that's actually attached to the first carbon gets 3 as well. So you still end up with the same number of carbons, same number of hydrogens. You just rearrange things. That's it. Okay. Using the outline steps, name the following molecules. You need to know your steps. You have to name your molecules following the rules. So I'm going to write a shorthand version of the steps that you had earlier. The first step was to identify the parent, right? The second step was to identify the substituents. The third step was to number the parent. But you can't just number it any old way. You need to number it so that the substituents have the lowest number possible. Lowest number possible. Okay. Then number 4 is you're going to name it, and you're going to list your substituents, then your parent, but the substituents have to be in alphabetical order. Okay. So if you need to do this on your exam when you get it, go ahead and do it. It'll take you just a minute. But get in the habit of practicing writing that before the exam time rolls around. Okay, so I want to find my parent. My parent is the longest continuous chain of carbons. So I could start here at the top and come down. That's continuous. That would be okay. That's 4. I could come across that way. That would be 4. I could start at the other end and come up. Or I could start at the other end and end at the first one. Doesn't matter. It's all the same. I've highlighted my parent chain. Now, identify your substituents. Right here, I have a methyl group. I want to give that methyl group the lowest number possible. So I want to start my parent chain as close to that substituent as possible. So which one's closer, this carbon or this carbon? This carbon is closer, so I'm going to erase, let me erase some of this. And I'm going to number my parent, 1, 2, 3, 4. And so I have my methyl coming off of carbon 2. So I'm going to call this 2-methyl. And there's no space between the substituent and the parent. And I have a parent that's 4 carbons long, so that is 2-methyl butane. Okay. Now, if I come look at my next molecule, I could go across 1, 2, 3, 4 carbons. I could go 1, 2, 3, 4 carbons. I could go 1, 2, 3, 4 carbons, right? All of those are possible. So let's just go across this way. Say that's our parent. Okay, what's our substituent? Right, here's a methyl. Now, I need to number my parent so that my substituent gets the lowest number possible. So if I started over here, this would be 1, 2, 3 methyl. But if I started from the other direction and went 1, 2, 3, 4, then my methyl would have a number of 2, which is lower. So I'm going to go with this one. So I'm going to do my substituents first in the name, put a dash between a number, 2-methyl butane. So these two are actually the same molecule. They're not drawn exactly the same, but they are the same molecule. So remember when we talked about this in class, we talked about this being an isomer. And this is just a conformational isomer. Conformational isomer. It has the same molecular formula. It has the same name. We just drew it a little bit differently, and that's fine. It's still the same molecule. All right, let's name some more. All right, remember when we talked about things in parentheses? What does that mean? That means that what's in the parentheses is actually attached to the previous carbon. So now let me number my carbons. And I don't know which way I want to go. So let me kind of try 2 different ways. Let me go 1, 2, 3, 4. That's a substituent. I'm not going to number it. 5, 6, 7. I could name my substituent. That's a methyl. So using this number system, this would be a 2-methyl. So let's see how that goes. Then we're going to go the other way. I could also go 1, 2, 3, 4, 5, 6, 7. Well, this time, as I go across here, why did I say 2-methyl? I don't know why I did that. So here, if I did 1, 2, 3, 4, this is the 4th carbon. So that would be 4-methyl if I was doing the blue numbers. If I do the red numbers, if I come across from the other way and I count, this carbon is still carbon number 4. So I'd still call it 4-methyl. So it really doesn't matter. For this molecule, it doesn't matter. So you could pick the blue, you could pick the red, doesn't matter. It's 4-methyl. And then the whole chain is 7. 7 is hep. Hep. And then it's all carbon-carbon single bonds. So it's heptane. The ANE means it's all saturated, all carbon-carbon single bonds. All right, let's look at another one. All right. When I try to find my longest continuous chain, my parent chain, right, I could start from coming over here. That's 1, 2, 3, 4, 5, 6, 7. That's one way I could do it, and I would get 7. I could go 1, 2, 3, 4, 5, 6, 7, 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Oh, that gives me something a little bit longer, right? So I'm always looking for my longest continuous chain. It doesn't matter how it's shaped, it's always going to be your longest continuous chain. Lots of people just want to go left to right, and whatever's coming off the straight chain, then that's the substituent, but it doesn't always work that way. So be very, very careful when you do this. So this would be a substituent, and this would be a substituent. So now my question is, which direction do I want to come in counting? Do I want to come in from the left or come in from the right? I can see that my methyl is going to have a smaller number if I start from the left, because if I started from the right, I'd go 1, 2, 3. Gosh, that I wouldn't have a substituent until 4, 5, 6, 7, 8. I'd have 4 and 8. But if I came in from the other direction and I went 1, 2, 3, 4, 5, 6, 7, 8, what would I have? I would have a 2 and a 5, and that's what I want. So I'm going to erase my pink numbers because I don't want those. And I'm going to go in and I'm going to name my substituents. I have a methyl at position 2, and then I have a 2 carbon, so that's an ethyl, right? So, and it's at carbon number 5, so it's a 5 ethyl. So if I look at this, I'm going to say that that is 2 methyl. Then I have to do another dash because it's going to be a number, 5 ethyl. Ooh, no, I got to do that backwards. Because remember, you have to alphabetize your substituents. So you want your substituents to go in alphabetical order. So think about alphabetically, E comes before M. So let's change that. So we're going to do 5 ethyl, 2 methyl. And then we name the parent. The parent is 8 long. So that's octane, because it's all carbon-carbon single bonds. So just be careful. Follow those rules and follow them. Okay. Now, when you look at something that's in condensed form, sometimes you're going to do better if you draw it out. So if I'm looking at these things in parentheses, what does that mean? I have 2 CH3s. How can I have 2 CH3s? Well, that means that each of the CH3s is coming off of this carbon. So this is a CH3, this is a CH3. So then I can just kind of scratch that out. And so I can see that that structure in and of itself, that's an isopropyl group. Right? Okay, so let's come back. I actually didn't follow the Dr. B, follow the rules. Okay, if I go across, I can't lift up my pen. 1, 2, 3, 4, 5, 6, 7. So 7 carbons long is my chain. If I went across and down, I couldn't get 7. There's no other way to get 7. So that's my parent. I got to know how to number it. So if I came from this side, that'd be 1, 2, 3, 4. If I came from the other side, that'd be 1, 2, 3, 4. So it doesn't matter whatever way you feel like doing it. 4, 5, 6, 7. Okay, so this isopropyl is at position number 4. So we call this 4 isopropyl hept. And then it's all carbon-carbon single bonds, ane, heptane. Okay. All right, here we go. So for this one, I'm looking for my parent, and I don't want to go up. I want to keep going straight, go straight. If I go down, I only get 2 more. But if I go straight, I get 1, 2, 3 more. So I want to go straight across on this one. You won't always go straight across, but try it out. So I have a methyl here and an ethyl here. Okay, now what carbon number are these at? And I can kind of look and I can say, you know, my methyl group's really close to this end of the molecule. So that numbering system's probably going to be the right one. 1, 2, 3, 4, 5, 6, 7. So it gives me something at 2 and 4. If I did it the other way and I did 1, 2, 3, 4, 5, 6, 7, that would give me something at 4 and 6. I don't want that. So I'm going to get rid of my greens. Oh, I was going to get rid of my greens. All right, 6, 7, we're going to get rid of. All right, so now we're going to go with the pink numbering. And so we're going to have methyl and an ethyl. Which comes first, alphabetically, M or E? E does. So where's my ethyl at? My ethyl is at position 4, so it's 4 ethyl dash 2 methyl. And then my parent is 7 long, so that's heptane. Okay, that was 2 methyl, and that was 4 ethyl. The more you write on your exam and on your paper, the better you're going to do. So make sure you write a ton. All right, so now we're going to name things that are in line diagrams. Fun times. Okay. So now I want to find my parent chain. So here we go. I'm trying to get my longest continuous chain, and I think it is straight across. Because if I went up at this point, I'd only have 2, 1, 2, whereas here I get 1, 2, 3. So that's my parent chain. Okay. Now let me go identify my substituents. I have a methyl here. I have a 2-carbon chain here, so that's an ethyl. And then I have a bromo here. All right, so now each of my ends has a substituent that's 1 away. So how do I know which one to start with? In this case, we're going to look alphabetically. What comes first, methyl or bromo? Bromo would come first, so this one would get the lower number. So I'd have to start my numbering 1, 2, 3, 4, 6, 7, 8, 9. So that's why I would number it in this direction. So my bromo is a 2, my ethyl is a 4, my methyl is an 8. And so I would name this alphabetically. First one is bromo. So 2 bromo dash 4 ethyl dash 8 methyl. And then I am 9 long, so that's nonane. Okay. Now B, let's try some other colors. Okay, B. I want my longest continuous chain. So let's see, if I start over here, 1, 2, 3, 4, 5. Now I got a decision to make. Do I go up or do I go down? If I go up, there's only 1. But if I go down, that's 1, 2 more carbons. So I want to go down. That's my parent chain. So I'm going to number them. But what direction do I want to number in? That depends. I have a chloro and I have a methyl. The chloro is 2 away from an, oh no, it's 1 away. It's 3 away. 1, 2, 3 away. This one is 1, 2, 3 away. They're both 3 away from an end. So now I got to kind of think about what direction do I want to go? Well, C comes before M. So I'm going to start from the chloro end. So I go 1, 2, 3, 4, 5, 6, 7. So I have 3 chloro and 5 methyl. So I got 3 chloro, LLRO, 3 chloro, 5 methyl, oh, no dash, and then 7 long is heptane. Okay. All right. Ooh, now these change a little bit. So remember, if it's a ring, we're going to call it cyclo. All right. So here we have a cyclo. All of these are cycloalkanes. So when you do this, remember that if you don't have any substituents, it makes absolutely no difference where you start your numbering. So I'm going to start down here. Then it makes no difference if you go clockwise or counterclockwise. So I'm gonna go counter. No, I'm gonna go clockwise. 2, 3, 4. So this is a cyclo, and then 4 is butter, right? Meat, peanut butter, so butane. Okay. Here, start anywhere. 1, 2, 3, 4, 5. So that's cyclopentane, because you're eating peanut butter in the Pentagon, right? Okay. Then, oh, more. 1, 2, 3, 4, 5, 6, 7. So this is cycloheptane, right? Because it's 7. All right. Now, when you get to one substituent on the ring, the numbering is important. When you get to one substituent, our parent is still our ring, right? As long as the ring has more carbons than the substituents, the ring is the parent. And so this would be a cyclopentane. And then what we want to do is we want to number, but give that substituent the lowest number possible, which is a 1. But then you can go clockwise or counterclockwise, doesn't make a difference. 2, 3, 4. Okay, so then this is our cyclopentane, and it's got a methyl group at number 1, and so we call it 1-methyl cyclopentane. Oh, and you don't actually need the 1 because it's understood. It's just like a molecular formula for like NaCl. We know that is 1 Na and 1 Cl, but we don't write the 1 because it has to be there. So for a cycloalkane, the substituent has to be at position 1, so we don't write it. So here's another one with 1 substituent. That 1 substituent is a bromo, and that bromo has to be at the lowest number possible, which is 1. So 2, 3, 4, 5, 6. We got 6 in the ring. So this would be 1 bromo, but we don't write the 1. So just bromo, cyclo, and then it's 6, so hexane. Okay. Now, things change a little bit when you get more than 1 substituent on a ring. When you get more than 1 substituent on a ring, there are 2 things that happen. If you looked at any given ring and you have 2 substituents, you could have 2 substituents that went up, or you could have 2 substituents where 1 went up and 1 went down. Or you could have 2 substituents that go down, so that are below the ring. Both of these are the cis configuration. If it's opposite, it's a trans. The other trans is 1 down, 1 up, but it's the same thing, right? So the 2 on this side are trans, 2 on the other side are cis. So whenever you have more than 1 substituent, you have to show, whoops, if it's cis or trans in your drawing, and you have to name it as cis or trans, because they're 2 different things, because that ring structure is, you can't twist it to where 1 could be up, 1 could be down. You can't twist it because you would break the ring. So our chlorine is one of our substituents, and then we have a methyl. Remember, if there's nothing there, it's a carbon. So this is a methyl, this is a chloro, and this is our parent. I'm sorry, I didn't say that. This is our parent because the parent's longer than the substituents. So the ring's the parent. So we would name this. Start with if it's cis or trans. See how this is opposite? One's a solid, one's a dashed. They're opposite, so it's trans, like a transatlantic flight. You go on opposite sides of the ocean. So trans, dash, and usually this is trans is in italics, but we can't do that when we handwrite, so just write trans. Then chloro, CHLO, chloro. Now, I missed something there, right? What has to be, I have to give it some numbers. So what numbers am I going to give? Well, either the chlorine or the methyl is going to get a 1. How do I know which one to give a 1 to? The one with the lower letter alphabetically. So chlorine gets 1. Then I have to decide which way to go around the ring. To give the methyl the lowest number possible, I have to go this way. 3, 4, 5. Okay. So trans 1 chloro, 3 methyl, and then it's a cyclo, and then it has 5, so this pent. Okay. So now you know how to do that. And because it's a cyclo, the first one doesn't have to have a 1 there. So it's kind of either way, but stick to writing it. It's much easier when you go to translate to write it. Okay. Now we got to switch gears. Oh, we have to draw the following skeletal structures. All right. So at the second carbon, and I like to write this. So on the parent, on carbon number 2, we're going to have a bromine. Then on carbon number 3, we're going to have an ethyl. And me eat, that's ethyl, right? So that's a 2 carbon. Then 4, is isopropyl. So remember, isopropyl is, we're going to be on carbon number 4, is going to be a propyl, which is 3 carbons, but you got to remember that that last carbon goes on the first one. So if it's a propyl, right, it would be 1, 2, 3, 1, that's 4. It would be 1, 2, 3, that's a propyl group. An isopropyl group looks kind of like a Y, right? Because it goes 1, 2, 1's coming off of the parent, and so it ends up looking like a Y, right? So this is part of the propyl, this is part of the propyl, this is part of the propyl. Whereas here, it's here, here, and here, right? That would be the rest of the parent chain. Okay, so make sure you know the difference between propyl and isopropyl. All right, and then heptane is telling us what? Heptane is telling us that it's 7 carbons and it's all carbon-carbon single bonds. Okay, so let's draw this. We're going to draw our parent first. 1, 2, 3, 4, 5, 6, 7. So, and you could have started going down, doesn't matter. Doesn't make a difference. So off of carbon number 2, so 1, 2, 3, 4, 5, 6, 7. Okay, so coming off of carbon 2 is a bromine. Then coming off of carbon number 3 is an ethyl. So I'm going to go down for 1 carbon and at an angle for the second carbon. Then coming off of 4 is an isopropyl. So there's 1 carbon, 2 carbons, 3 carbons. Okay. My next one, it's trans. This is telling me it's opposite. 1 ethyl. So on carbon number 1, I have a 1 me-eat. It's a 2 carbon group. Then on position carbon number 3 is a methyl. So methyl is a 1 carbon group. Then it's a cyclo, so it's a ring. Hex meaning 6, and ane meaning all carbon-carbon single bonds. Lots of information there, right? So now work backwards. Do your cyclohexane first. So this is a 6 carbon ring. And so what it's telling us is at carbon 1, there's an ethyl group. So I'll make that carbon 1 just for fun. And I have to make him some direction. You could have picked either the dashed lines or the colored in triangle. And that's only 1 carbon. I have to draw a line coming out of that to indicate a second carbon. Then I'm going to number it. You could number it any way you want. 2, 3, 4, 5, 6. So then on carbon number 3, I have an ethyl group. I'm sorry, on carbon number 3, I have a methyl group. So I'm only coming out with 1. And I think that's it. Oh, what did you do? On carbon, on the methyl, the 1 carbon group, I have to show that it's opposite. So I can't just draw a line because that doesn't tell me if it's above or below. So I have to do something that shows that it's different, right? And so that little dashed line tells me one's above and one's below. Okay, I think, oh, we got a few more. Okay, provide the names. So here we have a condensed formula. So this carbon is coming down here, CH3. So I just kind of scratch them out like that. All right, and so then I need to number them. But oh, as I'm kind of looking at this, I'm seeing I have another substituent right here. So right there, I have a bromine coming off right there. So I'm going to kind of scratch him out, right? So now I want to number them. Do I want to come in from the left or do I want to come in from the right? They're both on the third carbon in. So now I got to pick which one's a lower, which one's alphabetically better. So the bromo is going to be, this is a bromo group. This is a methyl group. So B becomes before M. So I'm going to want a number from here. 1, 2, 3, 4, 5, 6. So this would become a 3 bromo and a 4 methyl. And so I'd call this 3 bromo dash 4 dash methyl hexane. Because I have 6. Okay. Ooh, this is a long chain, huh? Let's see, what's gonna give us the longest continuous chain? And I think, yep, it's our straight chain. It's gonna give us our longest continuous chain. The rest of them are substituents. So the little thing that looks like a Y, that's the isopropyl. Then this is a methyl. And then this is another methyl. Okay, so now we gotta number it. And we're going to try and give our substituents the lowest numbers possible. The first one on this side is 4N. The first one on this side is 1, 2, 3, 4N. Okay, so which way do we want to number? Well, we want to give our substituents that have lower alphabetically higher priority. So we're comparing the P to the M. M comes first, so we're going to give our methyls the lower number. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and what do we get? That's 6 isopropyl, that's 4 methyl, and that's 5 methyl. So now I'm going to call this, I want to put my methyls first. So I'm going to say 4, 5 dash dimethyl. And then I need dash 6 dash isopropyl. And then I have 9 longs, that's nonane. Okay. The more you do, the better you're going to get. Ooh, I have a cyclo here. So sometimes I just like to write cyclo, just so I don't forget. Now, which one's going to get the 1? Which one's going to get the 4? The bromo gets the 1 because 3 long is a propyl. So B comes before P. So I have a 1 bromo and then 2, 3, 4, 2, 3, 4. It doesn't matter. So then we have now they're on the same side. So this is cis because this looks the same as this. So we have a cis 1 bromo. And I'll just remember to write that again. 1 bromo, 4 propyl, cyclo, and then 4, 5, 6 would give me hexane. Okay. All right, the next one, we want our longest continuous chain. We have to include the carbon that's got the chlorine. So once I get here, I'm going to go continue this way. Once I get here, I can go either way, doesn't matter. So then I have a methyl, I have an ethyl, and I have a chloro. Okay, so we have a methyl and a chloro, each one away. Chloro alphabetically comes first, so we're going to do that. 3, 4, 5, 7. So we have a 1 chloro, a 4 ethyl, and a 7 methyl. Oh, not a 1 chloro. a 2-chloro. 2-chloro. Okay, so we should be 2-chloro, 4-ethyl, 6-methyl, and then I'm running out of room. 7 is heptane. Okay. Provide line and condensed structure for the following. All right, so we got 2-chloro, 2-methyl propane. Propane is going to give us 3 carbons. So I'll do that first. Then coming off of carbon number 2, we're going to put a methyl group. Then that was this one. Then also coming off of carbon 2, I'm going to erase my 2. I'm going to have a chlorine. Okay, so how would I write that in condensed form? I would write there's a CH3, that's carbon number 1. That's carbon 2, that's carbon 3. So carbon 2 has 4 different things attached to it, so it gets no hydrogens. Then you would put things in parentheses around it. And so the chlorine comes first alphabetically, so it's chlorine, then it's by methyl, and then it's carbon number 3. And you could have drawn the sticks, but either way is fine. Okay, B, trans, this is opposite. Do a different color. Opposite. Then 1-iodo, 2-methyl, cyclo, telling me it's a ring, pentane is 5. Okay, so I need a 5-carbon ring, so that's kind of the house one. All right, and then we'll pick that one as number 1, and that's going to be iodo, but it's trans, so I have to draw 1 as the solid triangle, and we said that's going to be the iodine, and then 2 is going to be the methyl, so I'm going to do that as the little dashes, and I don't have to add anything to it because it's just 1 carbon. Cyclopentane, that's it. Okay, oh, but we need our condensed formula. So I'm going to start with the carbon that's attached right here at carbon number 1. So that carbon has 3 different things attached to it, so it gets 1 hydrogen. You have to still draw the trans. There's no other way to do it. You have to draw the trans. And then if you're going to draw the condensed structure, you have to write in all of the other things that are attached, right? So you could take that hydrogen and you could list that hydrogen as being opposite. Either way would be fine. Okay. And then here's a carbon. That's carbon number 2. Carbon number 2 has my methyl that is opposite the iodine. That's why, see, I like to do it like that. Then the important things have that distinction. Then that's CH3 there. And then that's a hydrogen. Then a CH2. That's carbon number 3, 4, and 5. So now we go up to CH2. And then we have another CH2 that those 2 bind to. Okay. All right. 1 bromo. So carbon number 1, we have a bromo. Cyclo, that's a ring. And butane is 4C. It's 4 carbons. So 4 carbons is a square. 1 bromo, pick anywhere. Bromine. So how would you do that as condensed? I'm going to pick carbon number 1 first, and I'm going to say, okay, there's a carbon. It's got a bromine. It's also bonded to a CH2. It's also bonded to a CH2. So if it's bonded to 1, 2, 3 different things, it only gets 1 hydrogen. So then CH2. All right, so there's your ring. All right, last one. I think last one. Yes. Draw the line structure for 2 structural isomers with the molecular formula C6H12. Now, then we also have to name the molecule. So if it's C6H12, that fits the formula CnH2n. So that could be one of 2 things. That could be telling you that you have a cyclo, alkane, or that could be an alkene. So let's draw them 2 different ways. So let's draw the cyclo molecules. So if I wanted to draw a cyclomolecule with 6 carbons, that would be cyclohexane. But I could also draw it as 1 fewer carbons in the ring and put 1 of the carbons on the outside. So this would be methyl cyclo, and then 1 less is pentane, right? And I could keep doing this. I could take 1 off and I could make butane, and I could have 1, 2, or I could do 1, 2, right? There's lots more. So like you could keep going and keep going and keep going, but we're not going to do that. So then let's talk about the alkenes. So the alkenes that we could do, let's do this. We need to have a carbon-carbon double bond, and we need to have 6 carbons. So that's 1, 2, 3, 4, 5, 6. So if I put in a double bond, this would be 1 hexene. Now, I can move that double bond to different places within the molecule, but this drawing and this drawing are exactly the same thing, because 1 hexene, I have to number my carbons from the largest substituent or the largest weird thing. So I'd have to number it from here and go 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. And the number refers to the first carbon that participates in the carbon-carbon double bond. So those two things are the same. Same thing if I do this. If I do 1, 2, 3. There we go. 1, 2, 3, 4, 5, 6. Yeah. Okay. If I do a double bond here, that's exactly the same thing as doing a double bond here. This would be 2 hexene, because I'd have to start 1, 2, and I'd have to start 1, 2. So it's still 2 hexene. The other thing that I could do would be to draw 3 hexene. So that'd be 1, 2, 3. So that would go right there. And that's the same thing as if I come in from here. 1, 2, 3. It's still the same, exact same drawing. So this is 3 hexene. Put a dash in there. Okay, that's it. I hope that helped.